what really affects the particular trajectory that you take are two things. One, your behavior. Number two, your genome, the source code or software. It gives you the potential to be very healthy or very diseased.
Dr. Lee Hood.
He's a geneticist, biotech innovator,
and visionary who helped map the first human genome.
creating a blueprint of human biology.
He is here to teach us how we can all slow down aging and prevent disease.
The major thing we're trying to do is optimize your health span. And we would like to extend it into the 90s or beyond.
Then what is the biggest misconception about aging?
Most drugs treat a symptom, but they don't cure the disease. We can manage most chronic diseases, which take 86% of our $4.5 trillion budget for healthcare today.
When you envision a perfect future, what do you see?
Within the next 15 years, we'll have the evidence to convince all of the skeptics that we should replace a disease-oriented healthcare system with one that focuses on.
To start with, you have so many great achievements in different domains like science, medicine, and also entrepreneurship. Could you tell us what drives you to do all those things?
Well, I think from the time I was 6 years old and my brother was born with Down syndrome, and this was back in the 40s. And I remember asking the doctor why that happened, and he had no idea whatsoever. That was what kind of catalyzed the idea that we really had to understand human complexity and how it gives rise to disease. And the history of my career has very much been going to Caltech and getting the fundamentals, getting an MD from Johns Hopkins. So I learned all about medicine and the most interesting problems I could attack. Yeah. And then I got a PhD in molecular immunology, which really gave me an idea of how complicated human biology is. I was at NIH for 4 years and kind of learned how to be an independent investigator before starting my real career at Caltech in 1970. And asking then myself the question every good scientist asks, what do I want to do with the rest of my life? I'm at a wonderful place. I have resources. Which direction should my career go? Yeah. So I decided at that time I'd like to go and understand human complexity and be able to unravel it so we could deal both with wellness and with disease. And in the beginning, it became obvious back in early 1970s, we didn't have the technologies for generating the data that was absolutely going to be fundamental to deciphering human complexity. So I set my lab up. Half of it was committed to technology development, and there we developed a series of 4 different instruments to read and write genes and proteins. And of course, the most important of those was the automated DNA sequencer. Yes. And that got me invited to the first meeting ever held on the Human Genome Project in the spring of 1985 at Santa Cruz, where with 11 other scientists, we were asked to consider whether or not there should be a genome project. Wow. And we concluded, number one, that technically it was possible, though at that time, very, very challenging. And we also were split 50-50, 6 on one side and 6 against it. Mm-hmm. And those against it were worried that for the first time, big science would come in and destroy small science and biology. And as a consequence, it took almost 5 years to persuade the community that the Human Genome Project was absolutely transformational. At the same time, I was doing molecular immunology And at the same time, I was beginning to understand some of the fundamentals of neurologic disease and things like that. So in the context of understanding technology, I wanted, one, to develop the tools,
Yes.
and two, to develop the strategies in biology for being able to handle complexity. And of course, one of the major strategies that we developed was a systems approach to human complexity. The idea being that you would take enormous amounts of data from each individual,
Yeah.
and that you'd be able to analyze it in the context of the biological systems that underpinned normal and disease physiology.
Yeah.
And in 2000, I started the Institute for Systems Biology, where we sit today.
Wow.
And its focus was to be able to apply this systems thinking to human disease. And we did that very, very nicely over that period of time. So that took us from technology to immunology,
Yeah.
to the genome, to more technologies. We actually developed 2 additional instruments. One of them actually used inkjet printer technology to synthesize thousands of DNA fragments very, very rapidly. And Agilent still uses that technology today in DNA synthesis.
Wow, that is very exciting to hear. Sorry to interrupt, because when I hear about you talk about the Human Genome Project, which is one of the most important, project that united the whole humans to sequence our gene, everything. And you have mentioned the start of the whole project with 11 scientists in a meeting, and then the project only brought up to life. So could you brought us back, because today when we think about genome, phenome, we almost, because of your research and your work, we think that's normal. But I think any groundbreaking technology come out in the historical point. I actually would love to travel back in time with you. Could you tell us what is the first meeting like?
So you'd like to talk about the first meeting of the Human Genome Project?
Yes.
Yeah.
Yes.
So this was sponsored by the chancellor at the University of Santa Cruz.
Mm-hmm.
And he had actually been my former chairman at Caltech, chairman of the Department of Biology. And he was the one actually that hired me to come to Caltech and encouraged me to do all of these things.
Yes.
And as I said, he invited 12 scientists from diverse fields in genetics and technology and computer science and things like that to come together and think about this. We spent about 2 days debating the pros and cons. And of course, one of the major contribution was the automated DNA sequencer that we were just in the process of developing, because you couldn't go anywhere unless you could automate DNA sequencing, because the old manual methods of doing sequencing would have been utterly impossible to apply to the 3 billion nucleotides that constitute the 23 pairs of chromosomes that are present in the human genome.
Yeah.
But as I say, we were divided between the issues of technologically and computationally, could we gather and manage that kind of data?
Yes.
And the general conclusions were we didn't have many of the tools for doing so, but we could certainly develop those tools. And the other sociologic question of, is it a good idea to invest $3 billion in the Human Genome Project? And that was what the initial proposal was. And of course, what was really interesting about that is when we went out in 85 and 6 and 7 and started proselytizing the biology community about the Human Genome Project, I would say initially 80% of the biologists were opposed to it. And again, they were opposed to it because they were terrified of big science taking all of the money from small science.
Okay.
And in fact, what was most remarkable is one of the most bitter opponents in the early stages of the Genome Project was the National Institutes of Health.
Oh, why was
And
that?
they argued that they were spending $300 million a year on genetics, and genetics and the genome were the same thing, which absolutely was a false statement and everything. But of course, when the Genome Project started in 1990, NIH quickly came around and realized it should play a role in this. And it did play a very important role in the project. I think one of the most successful endeavors we had in convincing people we should do this was persuading Senator Domenici, who was in New Mexico and had two big national labs that were interested in the Genome Project, to be a leader in this. And he made the argument, look, we can deal with the objections for most biologists by just saying the $3 billion for this project will be new money. We won't take it out of any of the pre-existing money for science. And that's exactly what happened, and what promised it. I mean, the other thing that was really interesting was, of course, then the emergence of new technologies and better and faster sequencing kind of technologies that led in 2003 to the ultimate genome. But the by story was this fight between the National Institutes of Health and Celera as to the strategy for being able to sequence and assemble 3 billion nucleotides. And it turns out that Celera, in fact, Craig Venter and I wrote a paper in Nature in 1996 arguing the only way to approach the complete genome was to be able to produce very large fragments of DNA and sequence those individually and then assemble them all together. And that absolutely turned out to be true. Celera proved it. And NIH, who really resisted that approach, was forced to come to a similar set of conclusions. And of course, the emergence of the entire sequence opened up then all of the avenues now that we're exploring with this data-driven science.
Wow.
One more point, I'll make two really interesting points. The Human Genome Project catalyzed technology developments that over the next 20 years after it was finished decreased the cost of DNA sequencing by 8 orders of magnitude. So today, you can do DNA sequencing for a few $100s a genome. And of course, the first genome cost way more than $1 billion to sequence. And the other thing that was very interesting is about 5 or 6 years after the genome was finished, the Battelle Institute did a study on the return on investment of the $3 billion that the genome gave us. And it was an $800 billion return on investment, starting new technologies and companies and all sorts of new things. So one of the key things that the Human Genome Project did was not just deliver the sequences, but it delivered the technologies that now enable us to use DNA sequencing to do things we couldn't even imagine at that period in time.
Yeah, for those of us who didn't know about the Human Genome Project in a very detailed way, could you explain in a very simple term as ordinary people like myself on the street that I don't know biology? So what the difference the Human Genome Project have made before this project happened in 1990s and after 2003 when it's completed?
I would say there were two really fundamental advances it made. So the first was the whole question of how many genes existed in this human genome. And the guesses at that time were 100,000 or more genes. And a gene, of course, is the part of DNA that codes a protein, and it's the proteins that are the machines that carry out all the biology of life. It turned out that the human genome only encoded roughly 20,000 proteins and not 100,000. And what the first genome did was essentially identify most of the genes that existed in the human genome. And that gave us the tools to go out and ask many questions about wellness and disease. But the second thing that was really revolutionary is the genome and its technologies gave us the ability to go out into the world of biology and to investigate the genomes of model systems, of microbes, of all sorts of different kinds of things, plants and animals. And they allowed us to understand evolution by looking at changes at the DNA level, the most fundamental level, and it transformed the fields of microbiology, of molecular evolution, and it really transformed with these technologies the fields of human biology and its applications, initially mostly focused on disease, but now increasingly start to focus on wellness and healthy aging.
Yeah. Am I okay to, because I'm not come from biology background and I'm trying to break down into a simple term. So am I able to understand in this way? After we sequence the human genome, we find in the manuscript of who we are in the DNA level, and after seeing it clear, we can basically interface with it before any disease show up because we know ourselves better from smaller level?
That's partly correct.
Okay.
So what the human genome is, it's essentially the source code or software for determining your health trajectory, okay? And so it gives you the potential to be very healthy or very diseased. I mean, different people are different. But what really affects the particular trajectory that you take are two things. One, your behavior with regard to exercise and diet and sleep and all of those things. And with regard to fixing the errors the genome has introduced into your source code, okay? And that's something we'll return to. But so measurements of your behavior and your environment are what we call the phenome. That is, the blood lets us view, the blood can be seen as a window that gives us insights into health and disease. And again, from a systems point of view, it does that because it bathes all of the internal organs. They secrete molecules into it. We can quantify those molecules and make predictions about the health status of all the different systems in the human body. So what the phenomic analysis allows us to do, it's actually viewing health exactly as the Chinese did 3,000 years ago. They stressed the idea that you have to look at the integrated body and you have to assess its individual contributions to the overall health. And of course, there they had the tools of perceptive doctors and the use of plants to create chemicals that could cure disease and so forth. And now we have these very powerful tools that let us interrogate the human being to optimize wellness. And there are ways that we'll talk about that we can avoid disease very effectively.
Wow. Then what is the biggest misconception about aging?
I think it's less a misconception than a lack of understanding. So let me say a little bit about why health is so important. I think health is important for two major reasons. And by health, what I mean, the optimization of that health trajectory for each individual. And I say it's important because it makes the individual realize their full potential during early development, during your schooling, during your jobs, during the community and interaction with people, and your ability to be creative and productive and energetic and so forth. So what we're trying to do with this new approach, genome phenome, to data-driven health, the major thing we're trying to do is optimize your health span. And that's the number of years you live healthily. And we would like to extend it into the 90s or beyond. And then we really get to an interesting question, because if you ask most people what they would do with an extra 20 years of productive life, many people don't have very good answers to that question. But it is an option that's going to be coming up, and we all should start thinking about that.
Wow. When you talk about the health span, what I understanding is longevity is not only about living longer, but much rather it's quality and happiness and full vitality, right?
It is absolutely essential. Look, if you have a lifespan of 106 and you're sick for the last 30 years of your life and have other people taking care of you, that's a pretty it's a non-optimal life. Whereas if you go into your 80s or 90s and you're vital and excited about life and capable of being creative and doing something useful for yourself or society, this is what's exciting. And see, the argument I'd make is that's true, one, of optimizing the individual and making them be what they can, but it's also that countries should push this idea, because you create creative people that are extremely wise, that have enormous amounts of experience, and it'll allow us to deal with a workforce that is now beginning to diminish because all the developed countries of the world are not replacing children at the rate adults die. There's not a replacement. And Japan has the most egregious example of this kind of thing. So if we can extend the productivity and life of individuals, then it'll make up for at least a part of the deficiency that is really emerging. And I think one place that's really going to see this enormously is China. And see, the thing is, if you have a long-term policy of one child, it is extremely difficult to reverse that. And that is because the major thing that changes is women have become emancipated and they don't want to be subjected by their husbands to the routines of rigid societies. And you see that in Japan, you see that in China, and you see that in the US quite clearly.
Reflect to something you have talking about. Two things I find is very interesting. One is when we develop from children to later stage of our life. I want to bring the topic a little into like everyday settings. I remembered when I was in school time, I realized the moment we all go to the middle school, which is achieving the puberty time, some kids they used to be kind of dumb and not so good in school, but suddenly it's like they turn on some switch. This became this kind of genius kid. Or some kid didn't grow tall until grade 3 of middle school, and then they suddenly grow. So let's say if we have a genome, like let's say we have a gene book come from our parents, right, the heritage, did this show or this function of who we are as a DNA show more in the later stage of our life or early stage of our life, or it just depends on the environment?
The answer to that is both. I mean, clearly the DNA creates the programs that lead to early childhood development and the enormous hormonal changes and the growth and the changes in brain.
Yeah.
And almost always girls develop more quickly than men do. And I remember my sister telling me not long ago, and she's still alive at 85,
Wow.
she said, "You remember back to the first grade, Leroy, I got better grades than you did at that time." So then, so I think there are differences in men and women, but your genome determines both early development and it determines the changes that make you increasingly susceptible to many of the chronic diseases like diabetes, cardiovascular disease, cancer, and Alzheimer's. Those are the four major chronic diseases, and those are the ones we really have to deal with in terms of prevention, not just treating them, because once you get them, the systems are so complicated that most drugs treat a symptom, but they don't cure the disease. And we see that again and again with cancer and Alzheimer's.
Yes.
I mean, the drugs there aren't beginning to touch the real causes of neurodegenerative disease.
Yeah, when we speak to that, I recall, I think I read about Angelina Jolie, who did a double mastectomy.
And oophorectomy, removing the ovaries. That's correct.
Yeah, so I'm just wondering, for the people who didn't know about, we can actually sequence our gene to see the dangerous of our potential percentage of the risk of we have certain cancer. What was the process of that look like? Just say if some people, they also have family history of cancer or diabetes, what will be their normal process to go to a hospital or go to some kind of institution to sequence their gene?
Well, there are companies that can sequence and interpret your gene. So I think if you come from a family that's rich in cancer or neurodegenerative diseases or any of those things, you really ought to have your genome done, because they will tell whether you've inherited high risk for those kinds of diseases or not. And for many of the chronic diseases, diabetes, cancer, and so forth, those are diseases that come up in middle and later stage years. So if you have I would argue everybody should have their genome done at birth, and your doctor should be given a catalog of the major genetic risks you have.
Yes.
And we don't have to worry about those genetic risks until, for example, the blood analytes and symptoms begin to resemble those, say, of a particular kind of cancer and so forth. And then you can be warned very early that you're likely to get this, and we can start to take preventive measures. So the idea, and another approach that the Phenome has done that's been very successful is, I started a company called Aerofailed that went for 4 years from 2015 to 2019, and it accumulated 5,000 individuals, and we did their genomes and phenomes across that period of time, and we saw 167 of those individuals transfer from wellness to various types of chronic disease. 35 went to different types of cancer. We studied 10 of these, and what we were able to demonstrate 10 out of 10 times is, one, there were proteins in the blood that were elevated years before the clinical diagnosis. And those proteins both pointed toward the early disease-perturbed networks that we could use then to do therapeutic prevention and reversal of that disease before it ever became clinically manifest and everything. So the hope with these two approaches is in the future we can manage most chronic diseases, which take 86% of our $4.5 trillion a year budget for healthcare today. We can have enormous cost savings and shift those savings to wellness, prevention, healthy aging.
Yes, then we're shifting from sick care to health care. And I imagine, that would be great if I know my, gene book when I was born.
Yeah.
When you envision this thing could happen in our medical system?
It's, so let me tell you, I proposed in the early 2000s the idea of P4 medicine.
Yes.
Or P4 healthcare, actually. It should be predictive, it should be preventive, it should be personalized. Those three Ps are all about science, and we know how to do them and what we need to do. But the fourth P is participatory. And the big challenge in healthcare is each of us is a steward for our own healthcare. Yeah. We're responsible to get educated about how we can optimize it and then follow the recommendations that come from that understanding and everything. So I think the fourth P, where we have to persuade patients, physicians, healthcare system leaders, healthcare technology leaders, regulators, politicians, on and on. How do we persuade all of these people to focus not on a system that's disease-oriented, where you don't make money unless you're dealing with disease, basically, to one that becomes optimizing wellness and prevention of these diseases? And I think that, and a lot of that ends up being psychological. How can we persuade people to do what's best for themselves? And that's not, there are a lot of really good ideas about how to do it, but we've only begun to study that aspect of healthcare, which is going to be critical in the future.
Yeah. I should flash back to another question on our genome and also our free will. So, Lee, do you think we have a free will as a human? Like when you see so many gene sequence and everything, do we choose who we become, and all come from our DNA?
So I would say, again, going back to the idea is the genome is the source code that gives you potential health trajectories, but it's the phenome and your environment that really specify which of those trajectories you end up taking. Yeah. So we have free will to make wise choices that optimize our potential. And I think there's no question about that. And we should use that free will to drive for a life that lets us realize the enormous potential each of us has as an individual. And the potential goes in all sorts of different directions in different ways, but each of us ought to be trying to optimize the potential we can direct toward whatever our objectives are. For some, it might be making money. For others, it might be, at least initially, being athletes and things. I think for myself, what has really kept me young, and I think basically vital, is a vision of what I want to do before I die. Oh. And it's going to take another 10 or 15 or 20 years to realize that vision. So I have lots to do, and I can see a clear path toward achieving those ends.
Yeah, clearly. But what is your vision in 10 to 20 years?
So the vision, I would say it's a threefold vision, okay? Mm-hmm. And I think each of these really constitutes one of the biggest paradigm shifts in healthcare that's ever happened in the last 5,000 years of civilized people. So number one, I think within the next 15 years, we'll have the evidence to convince all of the skeptics that we should replace a disease-oriented healthcare system with one that focuses on wellness and prevention. And I can tell you in a moment how I see doing that.
Yeah.
Number two, I think what's going to happen, well, let me say the way I think we can convince the world is something that I've called the Human Genome Initiative. And the idea there is to take 1 million individuals over a 10-year period, analyze their genome and phenome, and return the results to them that improve their health. And that project will do 3 important things. It will show how strikingly we can improve the health of each individual. Number 2, it will show we'll have trillions of dollars of healthcare saved by preventing chronic diseases.
Yes.
And number 3, it'll push technology just as we did in the first Human Genome Project to make phenomics, 1, very inexpensive, but 2, instead of being able to do the complicated blood analyses and so forth, it requires going to hospitals and things like that, increasingly will transfer an impedance match the multi-omic analyses with the wearable technologies, so that more and more the wearable technologies will replace them. And then we can envision a data-driven healthcare that is at home. Once we do that, it'll be mediated by cell phones. And that will lead to the second big paradigm change, which is the democratization of data-driven healthcare, because we'll be able to think about taking that to underdeveloped countries, all of which have cell phones and could begin to use these kinds of tools to improve their health. And then the third enormous paradigm change, the data that we've generated will really drive, is the introduction of AI into healthcare in a major way. And for example, what I see is having a close impedance match between each physician and a healthcare AI system that has the ability, 1, to take your genome and phenome data and identify and prioritize all the actionable possibilities that can improve your health. And then number 2, explain those to your physicians in a way that makes it clear what needs to be done, and at the same time gives him the clinical evidence that assures him that it's valid. And then number 3, we'll create chatbots that can go into each family that will explain to each member of the family what their data means and what their actionable possibilities are, why they should do them, how they should do them. It will be an enormous educational process that will close the loop of data to actionable possibilities to action to improve health. So I think 1, the transformation to a healthcare of wellness and prevention. 2, the democratization of data-driven health for the entire world. And 3, the absolute revolution that AI is going to make in its ability to deliver to the doctor and to the patient their means for optimizing their potential.
This is a very clear 3-step structure, and I think each one of them complementary each other.
That's
and
right.
I do see, because of my current job, I do interview quite a lot of tech entrepreneurs. They do wearable devices. And what I like about the wearables is actually gamified how I see my health. For example, I'm wearing glucose monitors recently, but then at least you have a choice to see, do I really need it or just driven by desires?
Right.
Yeah.
Well, I think with the glucose monitors, for example, they're really terrific for experimenting with your diet,
Yeah.
how you can control your glucose levels and so forth. And once you've done it for 2 or 3 or 4 2-week periods, then you should be really educated about how you can optimize your diets and what you don't have to wear them forever.
Yes.
Whereas there are other monitors that monitor physical activity and sleep and things like that I think are useful for giving you assessments each day of how you're doing and reminding yourself when you're deficient that maybe it's time to get up and do something and not just sit in front of your computer editing or doing whatever you do. Yeah.
Lee. Actually, think about that. I recall 2 weeks ago when I first hear your speech, when you're standing in the stage and you are so energetic, you are so charismatic. And I felt you must have a really great routine and the way you approach to your own personal health care. And I have to say, towards personal life, when I think about supplement, when I think about all the different treatment, it's got me dizzy. Like, I just feel there have so many information. So for average people like me and our crew, that we don't have a very comprehensive education in biology, what would be our approach to start to think about our healthcare, to navigate and also to optimize our health in daily life?
Okay,
That's a
I'll
big
tell
question.
you, I can give you a lot of recommendations.
Yes.
One, together with a colleague, Nathan Price, I wrote a book called The Age of Scientific Wellness last year from Harvard University Press. And I think that lays out the vision in a general sense very, very nicely. Yeah. And it tells you about what we can do today with the current disease-oriented system, but it really emphasizes the enormous advantages in optimizing health. And I think it really stresses, in a sense, you want to optimize health for 3 different aspects of your body. One is your brain.
Yes.
And that is one of the most ignored areas. The brain has to be exercised just like your heart does. You have to work it. And it's not just reading and working crossword puzzles. There ought to be different kinds of activity. And in the book, I have a chapter about what I think for cognitive health is one of the optimal approaches to really maximizing your cognitive health. I mean, what's really interesting about cognitive health is Michael Merzenich, who got the Kevley Prize for demonstrating that the brain is plastic, was one of the first to demonstrate for the average person, your cognitive health climbs to a maximum in your mid-30s, and most all of us fade away and get much lower as we age. What he demonstrated with 1,000 individuals is you could retrain most of those individuals to regain early cognitive function, so you don't have to experience cognitive loss if you age, if you know how to do the exercise. The second thing is optimizing your body health, and that's mostly what we've talked about. And the third thing, which is really key, is optimizing your microbiome health, because that's really important in generating the diversity of microbes in your gut that allows you to be healthy. And the more diversity they have, the healthier you're going to be. And we've demonstrated, for example, that the gut microbiome plays a really important role in aging. And we can think about re-engineering it in the future to optimize the aging process. We've demonstrated that the gut microbiome has a profound impact on a drug, a statin. showing that it can either enhance its good activities or enhance its bad activities, or do neither. So we know what kind of gut microbiome should be avoided. And it's going to be true for all drugs. We want to design a microbiome that lets us most effectively take advantage of drugs that are important for us. So the gut microbiome and the body and the brain, they're all three axes that go together to make you healthy. And we want to optimize and integrate their behaviors in a coordinated fashion.
Yeah, I do recommend people who are interested to learn more about lifestyle or processed medical or Dr. Hood's study to read that book, The Age of Scientific Wellness, because it's basically a really great complementary to understanding what Dr. Hood's study is about. And I actually would like to ask a follow-up question on the three pillars you have mentioned. So bring it back to the practical practice. What will be the everyday routine or the good neurohealth practice for our everyday life?
So what I would recommend is Michael Berzenich has generated a digital brain approach to assessing 25 different cognitive features. And it essentially is playing a series of games on your computer or on your cell phone and being able to follow and assess them. Those will tell you how things like your reaction time, your depth of field, your memory, how those cognitive features are functioning. If any are deficient, they have other games you can play that will that will optimize those functions in a very effective manner and so forth. So you not only can assess the cognitive functions, you can optimize them where they've gone down below the minimum that you'd like to see.
Oh, that's really fun because for me, I believe, our channel believe you should be a human aware, and the brain is the central CPU of every function to send a signal, or at least the major one. And many times while writing my awareness journal, I realized certain activity, for example, dancing or workout, they activate different part of my brain, or different part of my brain feels like they're juiced up. So if you think about that, when your brain as a whole mechanism of things, can you actually stimulate it? What's your opinion on neurostimulation and neurofeedback on cognitive health?
Oh, I think you can optimize your cognitive health just like you can optimize your heart health by exercises.
Yes.
I think you can do brain exercises that will really ensure you have maximum functioning indefinitely as an adult.
Yeah.
And the only thing that fails is if you have a disease where neurons are killed, then brain cannot replace. These exercises can't replace lost functions of neurons as we have in Alzheimer's and things like that. So there, it's really critical to prevent these neurodegenerative diseases like Alzheimer's or Parkinson's as soon as we can first detect them with preventive kinds of measures.
Yes. And then the second follow-up question on the second pillar in that health, holistic health, is the body, and what will be the good workout amount, because can you work out too much?
You can work out too much. And in fact, each individual has their genome and phenome give them a muscular distribution where you can have optimal exercises for you. And so the data-driven health in some cases can give us insights that say your exercise should be anaerobic and your exercise should be weight-bearing and intense to get the optimal benefits from exercises and so. So I think just as every individual's blood reflects your diversity, and we can adjust to the bad things that are present in your genome, so your musculature reflects that individuality, and we can begin to understand how to optimize exercise for each of us.
Wow, that's I would love to know more about my own genome now. And the last part is our microbiome. How do we, maximize our peak perform or stay got it into the peak health state?
Well, what I would say there is we're at the very beginning of understanding the enormous impact the microbiome has on your health. And we're even at a more primitive level in understanding how we can manipulate and reconstitute the microbiomes. But I would guess in 5 years, we'll have really effective methods for getting rid of the bad microbes and intensifying the good microbes. And we'll be able to have microbes that can maybe be specially effective for certain drugs that we could give you as you start taking your statins to deal with cardiovascular disease or whatever preventive measures lead to Alzheimer's. Those things we'll be able to enhance them with the manipulation of the microbiomes and all. But we're at I stress, the very beginning stages there.
Yeah, I think.
But on the other hand, we can certainly say what are healthy diets and what are not healthy diets today. And I think they're generalizations that are very important to understand and know in that regard.
Yeah, so make a conclusion of our last small topic is first you need to, use your brain. Don't scroll down on your phone all the time, so your brain will be, kind of getting dumb. Just use it properly and train it. You can do positive influence for your brain. Second thing is exercise, good amount.
Well, for the brain, the other thing I can argue is learning new things is one of the best things. So learning a new language, learning a new kind of activity, learning anything that's new that forces you to assemble information and be able to use it effectively. Those are all really terrific things to do.
Yeah. Yeah, actually, when you talk about learning language, I have a habit that every morning I get up, exercise, and then learning new languages for 90 minutes. And the one thing I realized is there'll be a moment that my brain can't process. It's like, I want to say this, but I don't know how to express it in this new language, but I'm such an expressive character. And then there'll be a moment of confused.
Yeah.
And your brain's trying, you think about computer, they're like probably running really, really hard. So I think learning new language is definitely one of my favorite exercise to training my brain daily.
Well, I'll tell you, when I go to sleep, often it's fun to think about a problem that I haven't been able to solve and to go to sleep thinking about it. And often in the morning, I can think about it in even clearer ways when I get up. So I think anything where you press new frontiers is really healthy for you, your brain and your body.
Yes. And also to follow up, our conclusion of the third thing is have a healthy diet because that's really good for your microbiome, right?
Yeah.
Yes.
Yeah.
And Lee, I think it's just so incredible when we learning about your past experience. I feel I'm so shocked how many things you have done, and you have either be founder or co-founder of 17 big organization or company. And what I understand is a lot of scientists, engineer, programmer, they are very amazing and well established in their career, but they turn the science paper into, a way of a company or in a way to really, practical way. Sometimes there will be a barrier, but it seems it doesn't happen to you. For example, one of your company, Amgen, that you guys have more than 25,000 of employees, which make it globally one of the biggest biotech company.
Right.
And we all learned that as a social animal, you can majorly influence maximum 150 people in average. How you even be able to start such a large scales of collaboration towards different countries, towards different companies? How did you do all of that? Just
There are two things that are really fundamental. One is having a really good big idea, okay? Data-driven health is something that I can convince almost anybody that it is really, really terrific. And in fact, about 4 months ago, I made a presentation to the new director at the National Institutes of Health about data-driven health, a 20-minute presentation. And when I finished, she turned to me and said, "This is terrific. This is just what we ought to do. Let's think about how we can do this together." And so with that kind of support, you can really think about big, ambitious ideas. For example, we talked earlier about a conversation I had with the director of an institute in Luxembourg that very much wants to do this data-driven approach and has collected all the hospital systems in that country, is convinced that the genome and phenome is going to absolutely transform healthcare and all. So we're talking about how he could become a leader in Europe and we could become a leader in the US for this international human phenome initiative, where together we could catalyze in those two different locales a million-person project, as we did with the first genome. The British contributed 25% of the first genome, and the US did most of the rest. But wouldn't it be great if we could have contributions coming from the EU and contributions coming from Asia and contributions coming from the US? That would be that. And then the diversity of genomes, which has enormous impact on your potential health, could be understood and could be characterized, and we'd be able to handle then any person with any mixture of genomes, because we could sort out the things that correlate with disease and wellness and all of those things.
Yeah, so you have mentioned to start such scales of collaboration throughout nations. First thing, you have a good big idea. What about the second thing?
The second thing is you really need to have very good people working with you, because I am a firm believer in small organizations are the one who absolutely catalyze change. And in fact, in part, the reason I left Caltech and I left the University of Washington was this whole idea of, if you get too embedded in organizations that are very bureaucratic, where the bureaucracy is honed by the constraints of the past, and it constrains their ability to see the future, then good new ideas can't thrive very easily from those things. And you have to take them out and create a new organization. So in addition to doing 18 companies, I've also done 5 different nonprofit research institutes, like the Phenome Health one, that's driving us forward in this regard. And in every case, it was necessary to get away from bureaucratic constraints so we could do what we knew was right.
Wow, that's beautiful to learn, because I feel sometimes it's even hard to influence one people, but to be able to influence thousands of millions of people, you need to have vision and also a killer crowd that you are thriving together.
Well, I'd say the third thing is you really have to be able to focus your persuasions on the leaders. once the CEOs, once the presidents, once the directors make those decisions, then you can go to the next level down. And it's very important to persuade the operations people that'll be doing it.
Yeah.
But you've got to start with the leader, because if you don't get them on board, you know, nothing is ever going to happen. And I've had really interesting experiences with big companies in that regard. You have to get the top guy first, and then you can, and then you have to go persuade the operations people too, and get them on your side.
That's a really good technique, because in China we have a saying: if you want to conquer a country, conquer the king first, capture the king first.
Absolutely,
like that.
You've got to capture the king first. Yeah, but it's every bit as important to capture the operations people afterwards. If you don't do that, you know, the king has power in making decisions, but he can't necessarily make things happen.
Yes.
You know, so the people who make it happen are the operations people who carry out the experiments and all. So anyway,
I think that's very interesting to learn as from an entrepreneur perspective to how to actually make big thing happen. I think it's absolutely amazing to have the ideas, but to executing those ideas is crucial, and
it is crucial.
Very important.
Yeah.
And could you walk us through what a typical day of yours look like? Do you take time off to have so many companies, so many projects? What is your routine like?
Well, the routine is one, getting up at 5:30 or 6, and then I do 40 minutes of exercise. And then I usually work a couple of hours at home and try and get writing and things like that done. And then I'll come in and spend much of the rest of the day as I did. I mean, I had one call with a new drug company that has a novel approach toward cancer therapy. I had a call with Luxembourg director, and we mutually got excited about collaborations in the future with the big Phenome initiative. And then I had a series of interactions with people. I'm speaking next Wednesday in Boston at a big cancer AI meeting, and I'm preparing the slides for that now. So I have a colleague helping me put all these things together. So we work through the kind of things we want to be able to present in 20 minutes. And the basic idea is to say, one, data-driven science has two approaches to the early detection and reversal of cancer, and that's how it's going to be done in the future. The drugs are never going to be able to deal very effectively with cancer when it's diagnosed, because it's so complicated. And then two, I want to talk a little bit about the Phenome and how we see it working. And the Human Genome Initiative that'll provide the data for the three paradigm changes we talked about and everything. So those are the I would say I typically have 3 to 5 or 6 Zooms or phone calls or meetings a day. And then try and get things done on the edge. And I'm writing an article for Scientific American now on how scientific wellness is one trajectory toward healthy aging, and gerontology of the Buck Institute is the second trajectory, and how they're beautifully coming together with very different approaches to science. The scientific wellness is big data, it's data-driven, it's discovery kind of science, whereas the Buck Institute is focused, intense, hypothesis-driven on specific aspects of what we know about the aging process now. So one is trying to do the global search of the body, and the other is trying to optimize the use of mechanisms we know affect aging, and they're beautifully coming together. That's why we join together to do these things in the future.
And could you tell us a little bit about the Phenome Health Project? And what was it, and where it is now?
So the Phenome Health Project, in the short term, has a whole series of features that we're working on. So number one, we are really going to push brain health very hard because we've got to get to that. And I've talked about how we can digitally assess cognition. I really want to bring in imaging techniques, which are very sensitive for looking at neurodegeneration and things like that too. So number two is this idea of thinking about how to integrate the brain, the body, and the microbiome, and put together those data and understand the interconnections and the actionable possibilities for each individual that can be derived from them. And then number three is to start Airveil 2.0, a company that corrects all of the errors we made in Airveil. And over the next 5 or 10 years, we'll look at tens and hundreds and eventually millions of different people in this data-driven approach to health, optimizing and determining the actionable possibilities for each, and using 3 metrics we have for wellness. So one is your biological age, the age your body says you are. Mm-hmm. So, for example, my chronologic age is 85. My biological age is 86 now.
86
is 70.
Yeah.
So I'm 15 years different. So I have plenty of time to do all the things I need to do. The second metric is a biological body mass index, BMI, and it's a very accurate measure of metabolism, much better than the classical BMI, that gives us a sense of how effective these new anti-fat drugs are and how you can stratify patients to use them more effectively and things like that. And then a third one that we're working on is a metric for fragility, the how fragile you are. And this metric is independent of aging. And it's, I think, going to be a very powerful new assessment of how to optimize, a metric to use for optimizing healthy aging in the future and so forth. And then, of course, we have 2 approaches to the early detection of chronic diseases and the possibility of reversing them. So that's what we're going to push. A third thing that we're going to do is take a big data approach to the 4 major chronic diseases. And we're starting with diabetes. And this project with 1,000 people is going to get started within the next month or so.
Amazing.
And the idea is to use dense data approaches, 1 for early diagnosis, and 2 to divide for each chronic disease the disease into different subtypes that'll require different treatments, so forth. And so that's cancer, that's heart disease, that's neurodegenerative, and diabetes. And then number 3, we're actually starting a new company using AI and phenomics. And there, what we want to be able to do is what I said before. 1, to take your phenomics and give you a prioritized list of how you can get healthier.
Wow.
Okay? And we'll do it by sending it first to your physician, and then we'll bring it to you through a chatbot that we're developing now that'll explain all the ins and outs of that kind of thing.
Wow.
And then finally, we've just received a $52 million grant from the federal government to work on 5 basic aspects of phenomics to solve technical problems so we can really push this thing forward in a very aggressive way. And then the final thing that we're pushing, and we're doing lots of lobbying in this regard, is the Human Genome Initiative, where we want to persuade Congress and the executive branch that this should be a second genome-like program where we absolutely transform healthcare by looking at 1 million people over 10 years with a genome analysis, and give us the ability to prove the health of each individual was enormously enhanced, enormous cost savings from the avoidance of chronic disease, and then the development of the technologies that'll drive measurements to the home and ultimately to the world of data-driven health. And then we'll have wellness and prevention, we'll have a democratization of healthcare, and we'll have AI-generated transformation of healthcare, making every family practitioner a domain expert in all fields of medicine because of the AI connection.
Wow.
You know? So that's the big view.
That sounds very exciting. Feel like I'm stepping into the future already.
Yeah.
And I think we all have a burning question now. Like, how am I going to get my gene sequenced, and how am I going to understand my phenome? Like, should I look for a certain company or certain clinic that could do it at this stage, or is still a process in the future?
No, it's very easy to get your genome sequenced now for $400 or $500.
Yeah.
And there are even companies that will sequence it plus interpret it for you. And we could recommend some of those for people who are interested. You could write to us at Phenome Health, and we could give some general recommendation. So I think getting it is easy. I think getting all the detailed interpretation that comes from the phenome is what doesn't exist. And that's what we want to bring into the equation.
Yeah, that's amazing. And to wrap up, I actually want to ask you one more time, what is your mission in life and what's driving you at this stage of your life? So
my mission is twofold. One is to see data-driven health pushes forward along these 3 paradigm changes that I've talked about. And the second is to make sure I have really healthy, good, exciting interactions with my colleagues and with my family. Because I think community probably is the most important single thing in healthy aging.
Yes. And if you could give our audience only one longevity tips, what it will be? Only one.
I think, I'll tell you, I've been an exercise fanatic since I played football in high school and college. And I can still do 150 push-ups every morning. I think exercise, and I'm at the weight I was when I played high school football.
Yeah.
Okay. So I think a control of weight and really diverse exercises that include stressing the muscles, but also include stretching and balance, especially for older people, is absolutely critical.
Wow. Lee, when you envision a perfect future of healthcare system, what do you see?
The absolute perfect healthcare system would be to push the Human Genome Initiative forward and validate the power and depth of it in collaboration with individuals in Europe and in Asia, so that we have the appropriate diversity to understand the genomes of all of the different individuals, and to demonstrate the enormous power data-driven health is going to have in freeing up physicians to optimize the health of all of their different kinds of patients. And I think with this tri-world kind of collaboration, I think the benefits that come from the analysis of all of the different populations could then be shared by one another in effective ways. And a sub-desire is the US healthcare system is absolutely chaotic now because it has 1,000 princes, each that control their own system and to a certain extent set their own standards, as we've seen by recent articles about the horrible diversity of quality of healthcare across the state. And I'd love to see an integrated system that was focused on data-driven healthcare that could bring to every American the opportunity to realize their full potential.
I want to contribute to that goal. It's just so beautiful vision, and I really, really believe preventative healthcare. Like that's my fundamental belief as well.
Absolutely.
Yeah,
Yeah,
I
I agree
appreciate
with
you
you.
starting off that.
Yeah.